In this video, we'll be looking at how to find missing terms in a geometric sequence. Now, just like with arithmetic sequences, we have a general form or rule for geometric sequences. That rule is a sub n equals a sub 1 times r to the n minus 1. Those different pieces are a sub n means the nth term, a sub 1 means the first term, and r is the common ratio between terms. So let's look at an example here. We want to find the ninth term of this sequence that starts with 0.25, 1, 4, 16, and so on. Now, right away, we can identify that a sub 1 is 0.25, and that's one of the pieces that we'll need for this problem. We also have to find what r is, and we have a couple options here. You can probably look and see that to get from 1 to 4, we have to do times 4. Or, if you didn't notice that, you could do 1 divided by 0.25, and that would also give you the same ratio of 4. Either way, we have to find what r is. Now we can go ahead and start filling our rule. A sub n is equal to a sub 1, which is 0.25, times r, which is 4, to the n minus 1. Specifically here, we are asked to find the ninth term, so 0.25 times 4 to the 9 minus 1. Well, that's the same as 0.25 times 4 to the 8th, and we can put that in our calculator, and I believe it comes out as 16,384. So you can see these numbers can get big pretty quickly, or sometimes small really quickly. Another example here. Find the missing terms of this geometric sequence. So we have 3, and then a blank, and then a blank, and then negative 24. So we're still going to try to use our general form here to fill in the pieces to find what we're missing. So we, again, can quickly identify that a sub 1 is 3. But we also, over here, have another term. We have a sub 4. So we can use both of those to find our common ratio. So let's say we fill in our pieces. A sub n, we're going to use a sub 4. So that's negative 24. A sub 1, we're going to use 3. And then we don't know what r is, but we know we're using the fourth term, right, n is 4, minus 1. Well, we can simplify this a little bit. We can divide both sides by 3, so we get negative 8 equals r raised to the 4 minus 1 is 3. Now to cancel out r cubed, or to get r alone here, we have to do the cube root of both sides, which will then tell us that r is equal to negative 2. It's okay, r can be a negative number. It'll still work even if r is negative. So we can keep going from here and pretty easily fill in the blanks. We start with 3 times negative 2 will give us negative 6, times negative 2 will give us positive 12, and then times negative 2 again does indeed give us the negative 24 that it should. Now, just like with arithmetic sequences, in geometric sequences, we sometimes aren't given a sub 1. So in those cases, just like with arithmetic, we're going to not use a sub 1, we're going to use a different term, some other term that we're given. And we're going to replace a sub 1, and we're also going to replace the 1. So let's look at an example. In this case, we're asked to find the 12th term of the geometric sequence that has a sub 3 equal to 4, and a sub 7 equal to 64. So we're not given a sub 1, but we do still have 2 terms, so we can plug enough stuff in here to solve this. We're going to kind of use a sub 3 as our replacement for a sub 1. And we're going to use a sub 7 as our a sub n. So we'll fill in the blanks. That means we'll have 64, because that's a sub n, equals, we're going to use 4 as our a sub 1 times r, which we don't know, to the n is going to be 7. And instead of minus 1, because we're using a sub 3, we're going to be using 7 minus 3. So we can continue to simplify from here, divide both sides by 4, we'll get 16 equals r to the 7 minus 3 is 4. From here again, we do the fourth root of both sides. So that's going to give us that r is equal to, in this case, it's actually going to be plus or minus 2. Now, a key thing to remember here, you will have to include the plus or minus anytime you take an even root. So I'm going to include this. When we do even roots. And the reason for that is both 2 to the fourth power gives 16, and negative 2 to the fourth power also gives us 16. Okay, so from here, we now can kind of write a rule to use. We're still going to use a sub 3 instead of a sub 1. So now I can say that our rule is a sub n equals 4 times plus or minus 2 to the n minus 3. So we're actually going to have to consider two different cases here when we go to find our 12th term. We'll have to consider the case where we have positive 2. We'll also have to consider the case where we have negative 2. So let's look at the positive case first. We're looking for a sub 12. That's going to be equal to 4 times 2 to the 12 minus 3. Well, that's just a sub 12 is equal to 4 times 2 to the 9th. And if we go ahead and put that into our calculator, we should get 2048. Now we also want to consider the case where we have negative 2. So this one will be a sub 12 is equal to 4 times negative 2 to the 12 minus 3, which is the same as 4 times negative 2 to the 9th. And if you put this one in your calculator, you should get a very similar answer. It's just going to be negative 2048.